This is actually one of the more important sections of this chapter, if not all, of trigonometry, because it really ties together and makes a connection between old school algebra and new school trigonometry. What I mean by components and magnitude direction is this behaves very similar to old school algebra. We saw that when we did some of our calculations. Okay, so this is old school algebra. And what I mean by that is if I gave you some numbers here, for example, if this was 3 and 2, that means you would move 3 steps to the right, 2 steps up, and there's the location of your dot, okay? And if I gave you new school trigonometry, what I'm going to do is instead of just giving you a left, right, up, down movement, I'm going to give you a direction. In other words, how much you spin, say 20 degrees, and then how far you would walk, and then you could land in a very specific location as well, identical to this idea right here. Okay, so all we're doing is trying to get to a place, either left, right, up, down movement, or spin and create a specific distance away from the origin. Okay, so the first thing we're going to do is we're going to convert from old school algebra. So if I gave you x, y components, which are like coordinates, and your job is to find the magnitude and the direction. Well, the magnitude you guys already know. The magnitude from here to here is basically, if I knew how much I moved left, right, and up, down, I could use the Pythagorean theorem, okay, to create that hypotenuse length. So it's nothing more than x squared, y squared. The direction is always going to be arctangent of y over x. We'll talk more specifically about why it's y over x later on. And also, please make a note of this. It is quadrant specific. So in other words, you got to make sure that you're in the correct quadrants 1, 2, 3, or 4, because sometimes, most of the times, your calculator won't know. So you have to be able to decipher that. Okay. So going from here to here is the trickier part. Going from magnitude and direction back to its component form is actually easier. So the magnitude is the distance and the direction is the angle. So if I wanted to find out how much I have to walk left and right, in other words, the x component, all I have to do is take that magnitude and multiply it by cosine of theta. There's my x, and I'm done. And then for my y, all I have to do is take that magnitude and multiply it by sine of that direction, that angle. So I have my x and y. Easiest way to remember this, x comes before y, cosine comes before sine. So whenever I say x in algebra, that's the same thing as cosine in trigonometry. Whenever I say y in algebra, that's the same thing as sine in trigonometry, and vice versa.